And welcome back. Gonna do something in acrylic today. So this will be a design log as opposed to review. And what we have here is just an old part I happen to have, uh, just based on measuring an actual old license plate I had. And use this as a base for my part because I need this basic dimension. So I'm gonna do a save as and make a new folder. Call this light up license plate. And I'm going to say this is light up license plate 0.001. Okay, so this is just, like I said, just measured from an actual plate. I'm going to need some variables in here. And don't know the exact thickness offhand. This will be acrylic, so it won't vary as much as with wood, but it's still good to have it as a variable in here in case I want to change the particular material supplier and it's a little bit different. And put curve right in there right away. I'll need it eventually. Might as well have it towards the top. And so what I'm thinking is that this will mostly be black opaque acrylic. And that's what surround material will be. And there's also going to be some clear material. That's going to be in the middle section. And what else do I need? Well, first, I want my safe disc. That's no. At no point should the acrylic be thinner than this when I'm cutting shapes out. And I'm going to set that to, I think 5 would be good. I might have to increase it later, but I'm going to design this to be parametric so that I can increase it. That's the whole reason that that's there to begin with. And let's see. Then I need to put some variables in because I have a bag of these LEDs and I've got various other kinds of LEDs, but I don't want to design just for this kind of LED, even though the prototype will be using these because these are white and there's nothing wrong with white except that some people might want a different color. So we're going to need to use variables that are driving this. So we got stay on that 3 and 4. Oh. I'm going to call this body instead. That way it matches up with the body height down there. So body height is 3, base height is 1. And as far as the other dimensions, don't actually care all that much for this design because these legs are just going to be kind of trimmed, soldered wires to them, and then trimmed as needed. So let's go back here. And I may need to add more stuff, but this is a good starting point. Now, let's see. This is all in one sketch here. So I'm going to go ahead and edit this feature. I'm going to say this is equal to my surround material thickness. And let's see, I'm thinking we want an outer border, obviously. So I'll start with that because I know where that's going to be. It's going to be on the outside. So let's see. If we go something like this, and this, and this, and this. I'm going to say these are all equal. And these are equal. And these are equal. And then do a coincident here. Do a coincident right here. And I just need one dimension in this sketch. Alright. So those will be the outsides. We have a little bit of an issue there, though, is that it's hard to do curves in laser cut stuff unless you're looking straight at the curve. So these are going to be like extruded straight up towards those flat pieces, and that makes it very hard to do the curve. So I'm not 100% sure how I'm going to deal with that yet, but I'll figure it out. So let's say this is going to be equal to our LED body diameter plus our safe distance plus safe distance again, because it's going to be top and bottom. And I don't want to merge this. So that's a starting point. And like I said, we got to deal with this. So what I'm going to try is make a rectangle here. And I can just say it's equal in width to this. And put a point in the midpoint and then make that also midpoint. Put a line in here. Doesn't matter if it's top or bottom, really. Make it for construction and equal. And that works. Draw in another rectangle. Get rid of this horizontal. See, this is collinear and equal. This is coincident. And over here is coincident as well. I'm going to do an extruded cut through all both. Okay. Then kind of do the same thing here. Rectangle, rectangle. Remove the vertical. Make it collinear and equal. Make this coincident. Make this coincident. And make this coincident. And make this equal. And put a coincident over here as well. And we can do an extrude cut through all. Don't have to go both this way this time because I picked the right surface to start from. Alright. So now we've got at least a tooth to give support to something that we put up in this corner here. Let's see. Let's start a sketch on this one. See, it's a rectangle, and it's going to be equal here, coincident there, and come on, if I can grab it, coincident there. So I will extrude this up, and I don't want to merge this. And kind of do the same thing again, except this time it's over here. merge it. All right. Let's see. If we go here, let's hide this just for a second and draw on a rectangle. Actually, that's the part we want to keep. We can just convert these two. And might as well do matching rectangles over here. Make those equal. Make these equal as well. Do an extrude cut through all, but only applying to this one body. And then let's do a sketch on this plane, and then hide what we're working on. And let's convert these and convert this. Show what we're working on again. Do an extrude cut through all and only apply to that. So now we've got about as close as we're gonna get to a corner there. I am tempted to somewhat to bring this out to a point, but I think that would cause some issues. I know certain cars are actually designed with that fillet in mind, including my car, so I don't really want to design something that's not even going to work on my own car, let alone a whole bunch of other people's. And to make it smaller, I'm not actually sure that would be necessarily a bad thing. If I wanted to make it square, I'd have to end it here, just for giggles. I'm gonna do a midpoint there. See how much I lose doing that. I lose 3.8 on each, so less than 8 millimeters if I do that, and it saves me from having to do this. Which means, basically I'm going to go back to here, delete all that, and it's going to complain that I just deleted a bunch of stuff, which I know I just deleted a bunch of stuff. I'm the one that did it. And delete this too. Cause another error with the equations. That's fine. I expect that. Close this. Okay. So how about go midpoint to midpoint, right click and select this chain, say offset of, I don't know, 100, doesn't really matter. Extruded cut through all. Now you got a nice rectangle to work with, and that's a lot friendlier. I like that a lot more. Okay. So, kind of start all over again on this. Say it's equal. Say this is equal to the surround material thick. This is equal to LED body diam plus safe distance again. Don't want to merge it. Okay. Then do the ends as well. So remove this horizontal, make it collinear and equal, and just to reduce the number of equations I need, make those equal. Extrude up to here. No, don't merge it. Alright, that works pretty much. Obviously still needs a little bit of adjustment, but get the basic idea here. a new sketch here. Use a midpoint. Actually, last time I used a midpoint and that worked fine. But just to show that there's always other options of ways to do the exact same thing. 2 lines, therefore construction and equal. And there we go. Exact same geometry, just a different way. And technically, you don't always have to remove these constraints when you want to do a horizontal. If it will usually let you do it, but sometimes later on during a regen, if you've got a whole bunch of features, it can have issues. So I like to just remove them preemptively to avoid having to try to figure out, hey, why is this thing suddenly failing? I'm going to do an extrude cut through all on these 2 pieces. Okay. I'm going to hide one of these end pieces. Do a sketch here. And I'm going to convert these. Go over here. Convert these. Show the end pieces. Do an extrude cut through all. Only applying to the end pieces. So now I got a spot where they can kind of lock together. It's still gonna need some kind of glue or something in here, but this is an electronic piece going on the front of the car, so I'm planning on potting this anyway. So then need something to attach here to here, or maybe not even attach. A line would be a better term. So I'm not going to go too crazy on the number of these. I'm not going to, try to make it square like I would with some of the other designs I do. I think just 3 teeth will be enough. If anything, 3 teeth might be more than I need, but well, drew in the teeth. Now I'm drawing in some construction lines. And I'm going to just select all these lines along the bottom and make them equal. There we go. And I'm going to extrude boss up to there. And I'm going to merge it. And expand this. Click just the sketch itself and extrude boss. Select this surface. Say I want to go up to this surface and merge there. And then, let's see. No, come on. All right. I'm going to select this. Actually, let's see. Got this sketch. Might as well keep using the sketch. So, got the sketch selected, extrude cut. I want to start from here, go through all, but the other way. Only on this. And do it again. All right, that works. Need to do the same thing on here. And since this is so much wider, I'm thinking go up to 5. Which, let's see, this is 20.9, so we'll see how that ends up comparing. Probably could have done this as a pattern. Probably should do this as a pattern. And make this for construction and equal. Right click to select this chain, linear pattern of 5. And I'll just set the spacing to 100 for now. And let's see, this is a for construction and equal. And start with the 20. So if it's about the same, let's see, what was this? 20.9, so let's just start with trying to make them equal, and we'll adjust from there. So 5 is not enough. 6, 7 is too much. So 6 it is. Delete this dimension. Do a for construction line over there. And make these two equal. Alright. And surface. There. And let's reuse the sketch over and over again. Extrude from this surface to this surface. Okay. And use it once more. Alright, so now I got a back panel. I got a border around it. And what do we need next? Well, the immediate answer, I think, is that we need an inside bit. So I'm going to do a sketch on here. Let's make a rectangle. Actually, I'm going to Control Z that. Make a center rectangle. And I'll select this chain and say offset. And then I'm going to change that value to equal surround material thickness. Alright. And I'm going to offset this. And I'm going to make that equal to safe dist. And make it for construction and tangent. So that gets me part of the dimensions. And then for here, the only real constraint I have is that I need room to have all the wiring and the back, basically the back sides of the LEDs, some wires, possibly some resistors. So I can actually just use a dimension for that. Let's see. That I'll go ahead and put it in here so I can adjust it later easily. I can never remember a channel has one or two. Well, whatever. Let's say I want 20 millimeters. That's fair. Alright, that looks good. I'm going to select this all, make it for construction, because I only want to do the top and the bottom right now. I'll do the sides in a separate feature so that they're separate. Grab that, coincident, and then I can just make these two equal. And extrude up to there. Don't merge it. And I want to show this sketch. Make a new sketch. And that. Do a coincident. Get rid of this horizontal constraint so that I can do collinear and equal and an equal. And do an extrude up to there. Don't want to merge it. Alright. And let's draw some rectangles again. Let's get rid of this vertical and this vertical. And these are collinear equal. And these are just equal. Do an extrude cut through all, but only applying to these bodies. Alright, I'm going to hide this, make a new sketch. I'm going to convert these, go over the other side and do the same. And show this body again. Do an extrude cut through all on those. Alright. So then, let me hide this, get that out of the way. I can hide this sketch as well. And I'll even hide this to get it out of the way. So last time ended up being like 20 millimeters each, and I did 3 of them. But yeah, I still want 3 of them, even if it means they have to be a little bit smaller. So 3 is right on the edge of where I want to do a linear pattern or not, but I'll do one. And put a couple construction lines in. So this is equal, 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 and equal. Alright, let's grab this, say it's coincident. Extrude boss up to there, and merge with that. Let's reuse the sketch on the other end. Alright. And let's hide this. How big did these ended up being? 14.8. So let's do a coincident. And go from there to there. It's going to be for construction and equal. Do a select chain so I can do a linear pattern. I'm just going to do 5 again. 30, just as a starting point. Make this for construction and also equal. Wait, did I? That was 7 originally, wasn't it? 1, 2, 3, 4, 5, 6. Okay. This for construction and equal. And we'll do an extrude boss up to here. And then we'll reuse that sketch from here up to here. Alright. I'm going to do a move copy body in the translate rotate mode. And I'm just going to select all 4 of these that I just made and copy them. And let's see, extrude 11 I need to keep visible, or make visible, and hide these. So then I can do a combine, subtract, and there we go. Do a save before I forget, because I like to forget. And we've got a starting point at least. Now, need to actually place some holes I need to figure out how many and how I want to place these, because however it is, it needs to be a multiple of 3, because these are 3-volt LEDs. So, and cars run a nominal 12, but it's not a consistent 12. Well, let me see. So these white ones run on 3 to 3.2. So in theory, I could just run this straight off of car 12 volt, I think. Let's see. So 12.8, and I've seen cars running into 13s pretty commonly. Actually, they call it a 12 volt system, but usually it's 12.6 on the, like if it's below that, you're probably not even going to be able to crank over. The tricky thing with this is I need to be able to take more voltage, or the same voltage. I needed to be able to take more voltage and cut it down to a consistent voltage that it's not varying in intensity when the car is under different conditions, like what parked versus driving. And the issue there just really comes down to dropout voltage. So my regulator is going to drop the voltage some all the time unless I use a buck boost, which costs too much money. So I got interrupted by the mail carrier, and then I did a little bit of researching, seeing what I could find as far as buck converters, boost converters, dedicated LED controllers. Looked at all sorts of different stuff, and basically I came to the conclusion that if I wanted something that I was of a quality that I could reasonably trust, it would just cost way too much to do something like that. And if well, there's really no if on that. It has to be of a quality I can trust. Otherwise, I'm not going to put it in there. But what I found is this part. It's just a linear regulator. It's nothing too fancy. But it's from Texas Instruments, so I'm pretty sure that it's going to actually work. It's on the pricey side, that's for sure, but it's still cheaper than a whole circuit board for a buck boost converter, even a Chinese one. It undercuts most of the Chinese ones. It's 750 milliamps, which is a little bit less than I'd like, but it's tolerable. I think it should be enough for this relatively small project. Supports up to 26 volts input, which is more than pretty much any car is ever going to be putting into this. And the important part is right here. The dropout was only 0.6 volts. So linear regulators, they just kind of they only reduce voltage. They can't increase it or even keep it the same. They have to reduce it. And normally it's like a 2-volt drop. So if you were inputting, say, 12.6 from a car's battery, you'd be at 10.6. And then the car cranks up, it's running at 13.6, now you're at 11.6. And either way, you're like not really regulating the voltage too well at that point, are you? Whereas this, if the car is at if car is under 12.6 volts on the battery, you've got bigger problems because your battery's dead. So 12.6 or more, and this will always put out 12 volts. And that way it's consistent lighting. So I think that's a good part to put in there. And it's a TO220 package, so it's nice and easy to solder to, even easy to mount. I feel like I used to have a 3D model of a TO220, but I couldn't find it, so I may have to draw one up. But yeah, that's what I think I'm going to actually use inside of this thing. So now we know I've got 750 milliamps. I'd like to have a 50% factor of safety on stuff like that. So 375 milliamps I can actually work with, I figured, or plan for working with. And these LEDs are 20 milliamps each, and I can actually stack 4 of them to get up that 12 volts. So let's see, 750 divided by 2 times 4 divided by 20. I can have 75 LEDs, which is probably too much. So that'll work. So let's say LED body diam is equal to that. All right. Have to think about how I want spacing. I'm thinking that I'm not going to have any LEDs in the side. I'm just going to have LEDs across the bottom and the top. That way, basically the light will be most intense here, and it'll slowly get less intense. But as it's getting less intense, it's getting more from the other side, and it should pretty much balance out. I'd have to do some actual practical experiments to verify exactly where it balances out, but I think you're not going to be able to notice the difference even if it's a little bit off. Whereas if I put extra LEDs over here, now this area is, and this area, or this area and this area would be most intense, and this area would be the least intense. So, yeah, that's my thinking pattern anyway. We'll see how she works. And do circle around here. Say this is equal to safe distance. And then I can go tangent here. And I can go tangent there. And let's make this for construction right away. I'll do a linear pattern here. And just for starters, let's call it 20. We can say tangent. Basically, I'm trying to find out. I might need less than this, but let's see how, if I actually max it out to the specs that I made, how much we can handle or how many we can fit. All right, so 30. Let's remove this tangent. Put a circle here. Say those are both for construction and equal. I'll put a tangent there as well. So that's 30 LEDs, 30 LEDs. So clear this. 60 divided by 4. So that's basically 15 sets of series circuits put into parallel times 20 milliamps, 300 milliamps. So we're well within the capacity of our 750 milliamp part. That said, this thing is going to be bright, I think. And I'm not sure it legitimately needs that many LEDs, because yeah, that is awful bright. So I'm going to dump this down to, say, 20. See how that looks. That's still a pretty dense array of LEDs, so I'm going to go with that. Just for math, real quick. 20 plus 20 divided by 4, 10 sets, times 20 milliamps, 200. So we're almost at a quarter, or a little over a quarter of what our linear IC can handle. So we've got LEDs sticking in here and LEDs sticking in there. And now that I've got nothing, now that I'm thinking about it, I've got nothing over here other than this, which these are roughly 11 millimeters across, give or take. So let's drop this down to, say, maybe 12. Do a Control Q. All right, that works, I think. All right, I'm gonna save this as well. Oh, and in there, I went ahead and just put a note for myself. This is the VReg that I found. And let's see. Then we need the actual display panel, I think. And how I'm going to do that is, actually I can show this sketch. I'm going to say, give me a plane. I want to be parallel to that and coincident with that. That works. And I'm just going to draw in a rectangle that's just coincident on all sides and the inside here. And that looks about right-ish. Say this is equal to my clear material thickness. I don't want to merge it, and I'm going to do it as a midplane. All right, and this sketch is, I need the sketch that drove that, and I'm going to hide that sketch. I'm going to hide this plane. And then next thing I need to do is, let's see, this material here is only 2.4 millimeters thick, whereas my LED's body is 3 millimeters. And basically I'm going to assemble this, and the LEDs are going to be sitting flush while I'm assembling it, because I want to be able to put in this display later. Basically, I want to be able to make, 2 or 3 of these in advance and then just drop. Now that I say that, I think I'll probably have stuff engraved along the edge anyway, so it'll be customized every time. Always conundrums, questions of how you're going to do things. Because right now the LED, if I stick it in there, it's not gonna sit on its base, which isn't necessarily a bad thing, but it's not ideal either. So I could make cuts into here. Yeah, that's what I'm gonna do. I'm gonna make cuts into there. So I'm gonna do coincident. I'm gonna grab this edge and say convert it. And then I can say coincident and coincident. And I can say equals LED body height. And I'm going to do plus 0.1. Just to give me a little bit of breathing room, because LEDs are not always exactly as dimensioned. And do linear of 20. Okay, gonna convert this one as well, just so that I can use it as a coincident. And then I'll make it for construction. And then I'm gonna right click here, select chain, or no, just right click, edit linear pattern. And it's gonna be 2 in the other direction as well. So I can do the top at the same time. And I'm also going to have to do a coincident to keep them in line. Alright, good deal. I'm going to do extrude cut through all, but only on this one body. All right, so now the LEDs stick through. They go into the material a little bit, and I think that's actually kind of a positive because that way you're getting some of the light from the side of the LED as well. And if I go with a LED that's thicker, I even get a little bit longer body. I get a little bit more of the effect, which a lot of times the rounded tip body ones are 5 or 6 millimeters instead of 3. And then what do we need? So right now this panel is just kind of floating there, and that's not ideal. How do I deal with that? I could just make it a little bit longer and sticking out and kind of locking into the side panels here. In which case, I wouldn't actually need these cuts at that point because I could use the actual plate to bottom out on, but that's neither here nor there because I already figured out that I think that's kind of going to be a bonus. Well, when I said I thought that was kind of going to be a bonus, I was thinking there'd be a plate here and here. Whereas right now I'm thinking if I extend this plate out and put some teeth here so it's locked in place, I don't need any supports behind or in front of it. I get a little bit more area. And the only thing that costs me is I have to move these LEDs back so that they're not shining directly at the person looking. So that's what I'm going to do. Sometimes you got to back out of an idea that seemed like a good idea at first, but now it's not. All right, so sketch 26, I'm deleting that. And for some reason, when you delete a sketch, SolidWorks keeps the equations from that sketch and then freaks out that they're not right because the sketch doesn't exist. So you just have to go delete them. All right, so this I need to modify. I'm going to hide this guy too, and I'm going to make, I don't know, 3 of them. I think that will work. It's going to be collinear and equal. And I'm going to get rid of the vertical. Get rid of the vertical on this one as well. Need some construction lines then. It's going to be equal, 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 equal. And hopefully that didn't screw it up too much. It did. Great. So equal and equal. And then these are going to be equal. And these are equal. And then this is going to be equal as well. I'm going to go a little bit wider than just past up to here. Actually, what I'm thinking is maybe double, just so that I've got a little, well, I only need a little bit more than what's already there. Just a little bit more, so that I know it's a little bit more secure, extra secure, whatever. Say it, just 1 more millimeter. And gonna do the same thing over here. Control Z. Actually, I can do a mirror for construction. Perpendicular and equal. Select all these. Say mirror. For construction. Coincident. Let's get this out of the way. And go up to here. That works. So now that locks into the sides. But I'm thinking that if this starts to want to warp a little bit, it's going to have a really nasty effect on the light. I want to keep this completely, very much in plane with the plane of the lights. So I'm also thinking I need have some like notches there or something like that, which might have to roll back and do a little bit of change to design to get that. So say let's make that, and let's say this is going to be equal to safe distance, obviously, plus safe. So I need the tooth is going to be safe distance. The area around the tooth is going to be safe distance, but in both directions. So this is going to be safe distance times 3. And that's a little bit bigger than I was kind of planning for. Let's drop this down to 15. And I'm going to stretch this out and say tangent with these. Make this for construction. And okay, so that works out almost ideally. So I can actually remove this tangent. That was more of a thing for measurement than anything. And then I can make this concentric. So now I'm down to 15 LEDs top, 15 LEDs bottom. Just realized I pointed at the opposites, but whatever. So 30 divided by 4, 7.5. Lovely. Great. 7 times 4 is 28, I believe. So if instead of 15 I make this 14, then that works. But if I need to divide it by, I shouldn't need to divide it by 3 ever. I think that works. Still a good number of LEDs, even at 14. That's 28 total. That's a good number of LEDs on here. I mean, beyond that, you're pretty much just too bright to look at even. And see, the spacing is 20 millimeters between them, so less than an inch in freedom units. So I'm satisfied with that. I can put up with that. So I'm gonna roll forward, and I'm gonna draw on this surface here a rectangle. It's gonna be coincident and coincident. And let's see if I do another rectangle and another rectangle, drag that out, and it's gonna, for construction, all these, gonna make these all equal, and just gonna manually select 4 lines for the center rectangle, make those not for construction, and tangent, and tangent. Okay, select this chain plus this, and I'm going to linear pattern of 19, spacing of 50 maybe, and go tangent here. Alright, what happened with that? Oh wait, we made 14, so 13 of them. Yeah, I was still thinking 20. Alright, so I'm gonna extrude cut through all and apply it to this and this. And then I'm going to reuse that sketch, do an extrude boss, and in this direction I'm going to go 1. In the other direction, let's say offset from this surface by 1. And I'm going to reverse the offset so it's towards the outside. And then I'm going to merge it with this plane, or this piece. So let's hide everything so I can show everything. Click Save. So now everything except for this is opaque material, probably black, although I've got other colors. 300 wide. Yeah, probably black because I don't know if I have anything that big in other colors. Then this is transparent stuff, and this can have something engraved on it. Jimbo's big old truck or Kyle's Audi A4, whatever someone might want engraved on there, it can be on there. Got the lights on the side so it lights up. And then we still have a couple of things to look at. The first concern is these holes. And it's kind of complicated by where these LEDs are. And yeah, when I had it at 15, there was also an issue there. If I go to more than 15, it doesn't really help. If I drop less to 14 that I have, I'm going to start to lose power. So I kind of need that there, but I don't have really any control over where this hole is. That's kind of the standard license plate hole. Some license plates have slots there, but this seems to be the hole that if you don't have a slot, that's the hole. So that's where it seems to be where screws are actually designed to fit on cars. So I could make like a square thing around, and then I just have to, for these 4 on the, that and on the top as well, I just have to bend the pins pretty tightly to avoid the square. And that's probably my best bet. Unfortunately, it's far from ideal, but it's still probably my best bet. Could do a diamond as well. I think a diamond might work better. It doesn't really matter if it's a square or a diamond here, so draw on this plane. I'm going to draw 3-point center rectangle. Something like that. I'm going to offset this and offset it by equals safe distance. Right. That's less than ideal, isn't it? Yeah, I keep running into issues there. So even if this is horizontal, it's still going to be right up against that. And how tall is my display right now? 103, or roughly 4 inches. And I don't want to really sacrifice much display area if I can avoid it. So I have to think a little bit. So my safe distance is 5 here. And that is important. I'm wondering if there's any way I could get around it by maybe having something that isn't acrylic right there. So I'm going to cancel this sketch. Start a new one. What if, since these are relatively small spots, what if those were not acrylic, or even laser cut for that matter? What if these parts in particular were 3D printed? So for the 3D printed part, I can get away with some pretty small sizes. So start by converting that. And if I offset, I can go say, even a 1.5 millimeter wall is enough with 3D printing. So say for construction, tangent, and equal. So then I've got room to work in there. And plus, if this is made out of ABS or even just PLA or PETG, it's going to be a lot stronger in regards to over tightening screws not causing a crack. And I think that, actually, come to think of it, that right there is a major advantage to going this way all by itself. So that is definitely it's an accidental additional feature, but it's a good one. I don't want this thing cracking when someone tightens it down a little bit too tight, and that is not going to happen if they are using, or if they're tightening it into something that's more flexible. And even if they do crack this particular insert, they don't crack the whole thing. So we got a winner of an idea there, I think. So we got the rectangles all set up. And I'm wondering, do I want to round the edges at all? I know. Yeah, I'm thinking, do I want it square or not? And I don't think I do. I don't think I want it square. But I used constraints that are going to get in my way if I try to put fillets on there. So I'm just going to convert this whole sketch and hide it. And I'm just going to put relatively minor fillets on here. I don't want it to be full round. I don't think. Yeah, because I don't want it to be full round because it'll turn. And I don't want fillets on it because I've got hard edges. All right. Grab just the parts that I want to keep. Yeah, sometimes you got to go back and forth on a design until you get it the way you want it. There we have a winner, I think. So do that 3 more times. And just say these are all parallel and equal. All right. Then I am going to extrude up to there. Say don't merge. And I wonder if I do want this to be pressed against this back piece. I don't want it to go through. I don't want to make a hole for it to go through, because I want that to actually help hold this whole thing down. So I'm happy with that. I have to figure out how the front piece. I want to close this all in. I have to figure out how I want to do that. And well, let me just start from the beginning on that and see where it takes me. So I'll close up all this to there. And gonna extrude equals round material thickness. Don't merge it. So that's basically what I'm looking for. And let's see, we got this sketch. I'm going to say extrude cut from this surface through all and only applying to this. Cancel. We don't want to use that sketch. We want to just convert that sketch So we can remove these circles. All right. And these, say, let's edit this feature. Instead of up surface, I'm going to say offset from surface. Reverse this offset. I'm going to say equals my surround material thickness. And okay. That way those are even. And people will probably still put a washer on there. In fact, I'll probably supply a washer with it just to be sure that they do. Or 4 washers rather. And yeah, that's starting to look right. I need something to lock these edges in place, which will probably just be the same as this. Let's see. This is 4.33, 4.33. So yeah, if I extend down or extend up the same as I extended down, that'll work, I think. So do a coincident and a coincident. Select this, do a linear pattern of, what was it, 1, 2, 3, 4, 5, 6, 7. If it's 6, I can always back off. That was wrong. One there, yeah. All right, yep, it was 6. All right, that works for me. Let's get this out of the way. And extrude up to here. Actually saying that, I'm wondering if I want cuts in the face. And I'm thinking I don't. So what else? How else can I address that? Ah, I've got it. Let's hide this. Yeah, I don't want cuts to the face. I mean, on the back here, it doesn't really matter, but I don't want these on the face. So what I can do is I'm going to do a little bit of just basically engraving on the back side of that front plate, which is not 100% ideal because I also want to be able to engrave on the front side of that plate. But I don't really see any alternative. So I'm going to draw this rectangle. If it'll let me. Come on, gimme. There we go. So I'm gonna extrude cut the other way. It's only gonna be like 0.2 millimeters, hardly anything. I'm gonna hide this and sketch here, say convert this and convert this and extrude by 0.2 millimeters and that and that. Do another sketch, basically doing the same thing but for the top and bottom. Don't bother me right now. All right. So at that point, this isn't really held in by anything. Well, none of the panels are really held in by anything other than the fact that I'm going to be after I install the LEDs, I'm going to be basically just filling up the cavity with, not 100% sure, maybe silicone, something to pot in, because it's going to be at the front of a vehicle, and I don't want it to get ruined. I mean, rocks and stuff, I can't really help if rocks hit it or whatever, but I don't want it to be ruined by water. So yeah, at this point, it's pretty much set. We've got a nice little border. We can put text there if I need to. Maybe even along the sides if they want. We could do the design right in the middle. It's all LED. Yes. How does it get its power into it? That's another issue. And and ideally it'd be right in the middle, but that just isn't going to work, because then you'd see the wires through the clear material here. So it has to be some kind of port around here. And probably dead middle, dead center is going to be ideal. And top, I want to say top just because, it's less likely to collect moisture and stuff at the top, I believe. And for construction, how big is that? Almost 9 millimeters. It's plenty to pass power into this thing. So all right, so power comes in there, and let's see. Yeah, power can come in there with like a strip cable or something, and I'll have to route it over to here, which will be routed around the outside of this, I think, if there's room. There is. So it routes over here, goes into the linear voltage regulator. The ground along the way can already start being routed into there. And then the power coming out of the regulator can go into all there. So I think that's pretty much works as a design. Again, all this is going to be filled in and potted. And I'll put enough that when I put the top on and press it in place, that'll also be held in place by the same stuff, which will also lock this plate in place forever. Yeah, I think we got a decent design there overall. These slide in and out, but they'll be potted in place, so that's not really an issue. If I make them below the surface, it might look better, but I don't think you're going to see them anyway, so I'm not too worried about that. But yeah, I think we got a winner here. So I'm going to take all these features so far, and I'm going to throw them in a folder, just calling it model. Going to hit save because I need to save more often, and I never remember to save. Then I need to basically start going through the components. So sketch, offset. I'm just going to do a 0.1 offset, and then I'm going to say this is equal to that. Get rid of the default part. Divided by 2. I'm going to copy and paste this a bunch of times, so might as well make it a little bit shorter so it's easy to read. To surface, this surface, and yep. And I'll show this one. I can reuse the same sketch on that. show this one, hide these two. These are much easier to do the offsets on just because there's not all those tiny little teeth like in previous designs. And we'll hide those. This one I can't copy and paste because it's slightly different. Nope. Up to surface. Getting butterfingers here. Alright, and I think these are all 3D printed. So, don't need to do kerf on those. So an engraving like this actually kind of has the opposite kerf. So it's a little bit hard to get it right. And I didn't even create a thing, so. They're about, I may need to do a little bit of dialing in on that. So let's say this is offset, and it's going to be equal to that divided by 2. And I will do an extrude cut up to this surface, only applying to this right here. All right, and we convert all inner loops, and say offset, reverse, and do a paste of that, and do an extrude up to surface, there, and that'll kind of screw up the last thing that I did by doing that, so I can just go like that, and I'll fix it. So I'm going to convert this and do offset. And this will just do around the outside. So that's done. 22. All right. We're running out of parts that we need to kerf. And whenever I can and I remember it, I like to just reuse sketches. Keeps everything a little bit simpler and more efficient, and well, more efficient for the software and more efficient for me. So double bonus. All right, and this is a little bit more complicated part, but not a big deal. I'm going to convert all the inner loops, and then I'm going to select all the inner loops, and I'm going to make them all for construction. I'm going to offset them, reversed, and say it's kerf divided by 2. I'm going to offset the outside, not reversed. It's also kerf divided by 2. And then extrude up to here. And then reuse that sketch. All right, and then cut 20. Let's see. First cut here is 21, so yeah, we still have, I think this is the last thing I have to do. So let's convert all inner loops, make them all for construction, offset them all reversed. I'll offset the outside not reversed, and then just put curve divided by 2. I'm just copy and pasting all these because why type it every time? Up to surface, that surface, and there. All right, and then the first part other than the 3D printed, the oldest part or body is boss extrude 24, which is that. So at that point, everything is curved. So I'll throw all this in a folder called curved. And saying that, I'm thinking I want to get a better idea of how this thing actually looks, because right now everything is a color that it's not actually going to be. So I'm going to say edit material for the whole thing. Plastics and acrylic. Not sure it's going to let me, it's going to look right. It's probably going to be transparent, yeah. See if I can edit the appearance with it. It's probably about as good as I'm going to do without turning on the higher quality rendering, which I don't want to do because it slows things down terribly. And it's going to be acrylic apply. So that's semi-transparent, as you can see. And these are ABS or whatever, but the color's about right. Yeah, it's not exactly photorealistic, but you at least get an idea of what it is. And the sides will be all lit up. So this, somewhere in there, there'll be engraving, and it'll just be like glowing and looking all pretty. So what's next? The last thing that needs to be done, since it's going to be laser cut, and I don't want to cut it one piece at a time because that's ridiculous. Well, first let me get this out of the way, and get this out of the way. Alright, so I'm going to move copy bodies. I'm going to say this is coincident with that, and this is, I want outsides matching. So this is, well, this is going to be the outside because this side's mounted against the car. So I'll constrain those first. And they're so close I can't actually get at them. So what I can do is I can just go like this and say 33. Why not? And then I can't undo it, and I can't make this feature and then delete it because it'll go back. But what I can do is I can take and just delete the faces, and then it lets me do it. I don't want to insert part. I want to, well, I'll start with here. Just like last time, do that. Just like last time. And just like last time, we did the same thing. And delete. 2. Okay. All right, that looks looking good so far. So it's time to go like that. And this is the outside face this time. And I don't even know where it went. It's probably like that. Yep. Okay. And yeah, I'll go with this side. Alright. Do the same thing with this one. Actually, another way I can do this that's a little bit less troublesome. So I can just make a plane just 1 millimeter away. Mirror. Geometry pattern. Oh, I want bodies. That's why. I don't know why it always defaults to mirroring features. Every time I try to mirror a feature, it ends up throwing an error, either immediately or when I rebuild. So, never use that. I can just delete this. It's 3 features instead of 1 feature, but it's an easier feature, so I'll take it. And let's move this. Right. And got kind of wasted material there, but it doesn't have to be a waste. So this is going to be made with that the other way. Okay. And this, oh, not that, this. It's going to mate with this. And call it 2 millimeters. And now that piece is inaccessible to me, so I'm just going to finish that mate, hide this piece, start that mate again, and 2 millimeters. Okay. And I'll do that mirror thing again because that is much easier. And this feature, I can just add this body. I might as well add this one too because I'm going to get into it soon enough. Alright. Let's see. Let's move copy bodies on this. Yeah, I want to make sure I'm getting the outside matching. Flip that. And I do have a little bit there that I can grab on and do my dimension trick. That works. I can go like that, and that, and that. Alright, so clearly I'm still going to be wasting a little bit of the material in the cutout area, but well, that happens sometimes. It won't be waste exactly, it'll be scrap, and I'll probably find some other use for it at some point. So, if I hide bodies and show bodies, this is going to be cut out of a separate piece, but I might as well move it out of the way at least. Okay. And we got our 4 3D printed parts, which we want to move those out of the way as well. And rather than moving them all separately, I can just do a mirror. And a mirror. And where was that? Delete copy body, or delete body. So that. Alright, so Everything is flat. Looks good. I'm going to hide these planes that I don't need to see. I'm going to hit save. When I was doing that, I did notice one thing that I want to adjust, which actually should have come before kerf even. But it's alright, I can add it at the end. It doesn't really hurt anything. And that is these edges. See, they're a millimeter sticking out. And I'm going to give them a millimeter of a chamfer. So they still have full contact on both sides, but the part sticking out is chamfered, which makes it easier to install. I'm still getting the advantage of them sticking out because that's mostly on the top and bottom surface. And so, I might have been better off doing this as a pattern of like drawing them in, but well, I'm already like half done, so maybe not. And just one more side. And okay. And I'm going to do a normal 2. I do a control Q just to regenerate everything. And I'm going to click save. And I've got a design that's ready to go. So at this point I can export a DXF and use that. I can obviously I have to put some kind of design on here. Maybe even some design around on this surface. And then I have to also export these as STLs and print them. But yeah, other than exporting to go to the manufacturing stage and the customized graphics or whatever that go on them, this is all done. So if you stayed this long, thanks for watching. And if you got any questions, please put them in the comments below. Otherwise, well, see you on the next video.